All right, so, sorry. This is going to be halogenation, electrophilic aromatic substitution with a halogen. And so in this reaction, you're going to go from a benzene to a benzene with a halogen on it. And so it's important to remember this can be, I don't know why I put Br there, sorry, Cl, Br, or I. You can't do this reaction with fluorine, unfortunately. And the catalyst, remember, this reaction requires a catalyst because the benzene is so much more stable than an alkene. We can't just do, you know, if this was, I'll erase this. If we had Br2 alone with cyclohexene, we actually wind up with electrophilic addition. Right? But if you do this with benzene, you get no reaction. You have to have the catalyst here, okay? Because the benzene's a lot more stable than the alkene. All right, the catalyst is either iron trihalide or aluminum trihalide. You can use either one. I'm going to show the reaction. I'm going to show a bromination with iron tribromide. Okay, so you have to generate the electrophile. So how does the iron tribromide, this is the catalyst. How does it act as a catalyst? Or you can't just say it's a catalyst, it makes the reaction go. I mean, you can, but you're not gonna understand the reaction. And so the reaction, iron is a metal. It's a really not very electronegative metal. But it's a strong Lewis acid, I guess is what I'm trying to say. It's an electrophile, it's a strong Lewis acid, and so you get a reaction where a lone pair on bromine reacts with iron, and now look what we get. Minus. And that could be, that is probably the catalyst. So we can get reaction here. Okay, this will give us positive. Or this catalyst here could give us Br plus iron tetrabromide. And then that Br plus reacts with the Br plus is the electrophile with the benzene. I don't care how you do this, all right? And in fact, I'm not all that worked up about this mechanism, this part of the mechanism here. It's the organic part of the mechanism I'm interested in. And I'm happy for you just to sort of say that if you see X2 and iron X3 or X2 and aluminum X3, that you simply are going to end up with X plus and use that as the electrophile, right, in the mechanism. So if I ask you to draw this mechanism, you would just use benzene attacking Br plus or Cl plus or I plus. And I'll tell you, under most conditions, the benzene's probably reacting with this species here. But there is an equilibrium like this. Now, what's the base? We got to have something. We got to generate HX. We've made our carbon X bond, but we have to pull this proton off. Well, it turns out that iron tetrabromide exists in equilibrium with Br minus. So Br minus and iron tribromide, and so then this Br minus can take that proton, and this generates the product. And our catalyst is regenerated. So the catalyst is a true catalyst in this reaction. It gets reproduced over and over. All right, so that's the mechanism for halogenation. If you did this with chlorine, if Cl2 and iron chloride, you'd replace these with chlorines, you'd replace that. You always want the Br here to be the same, the halogen here to be the same as the halogen here, because you're going to get this complex and it could rearrange. And so if we had chlorines here and bromines here, we'd get a mix of bromine and chlorine on the final product.